Welcome to this complete guide on outliers detection and treatment. In this tutorial, we will try to understand what are outliers, what are different techniques to detect and treat the outliers. We are going to implement these techniques and methods using Python and different Python libraries like pandas, matplotlib, numpy, and seaborn. So let's first look at what we are going to do. First, we'll try to understand what are outliers, why we should handle outliers, what are different use cases where outliers are important, what are different techniques and methods to detect outliers, and then finally we'll move to the different techniques and methods to find out that how we are going to treat outliers. So first we will prepare dataset. Then we are going to implement different techniques and methods to detect outliers. Here you can see graphical methods and then statistical methods like z-score and interquartile range. We will talk about interquartile range. Then we will move to the how we are going to treat outliers. There are different techniques and methods to treat outliers, like you are going to remove or trim the outliers. You are going to cap or floor. So we are going to capping or flooring the outliers, imputation of outliers, and data transformation of outliers. So these are the things that we are going to implement in today's video. I will upload this notebook and the dataset that I am going to use to GitHub. You can download notebook and dataset and you can practice. So let's first understand what are outliers. Outliers are basically those data points that are very far away from rest of the data points, most of the data points. So in this example, you can find here that this data point, that is 185, is very far away or very distant from the most of the data points. Most of the data points are in between, let's say 50 and 125. And this data point is very far away from the most of the data points. So we are going to treat this 185 as outlier. There are different examples in our daily life. One example that you can find here, in a data set of employee salary, if you are going to include salary of CEOs, so that salary of CEO will more likely be an outlier. One important thing that you have to focus that outliers, most of the time you will get that these are the valid data points and important data points. So you are not going to ignore those data points. You have to handle, you have to treat those data points. So let's understand why we should handle outliers. The first point is that the outliers can distort the statistical measures. There are different statistical measures like mean, median, mode, standard deviation, variance is there, skewness, kurtosis, different statistical measures are there. What is the purpose of statistical measures? Instead of going to learn whole data set, we are going to understand the data set using statistical measures. And if in the data set we have outliers, so our statistical measures, these measures will be distorted and we are not going to get exact information about the dataset. So we need to handle the outliers. The second point is outliers can impact on machine learning models. Let's say that you are going to create a machine learning model. You are going to fit a straight line for these data points. And one outlier is here. So if outlier is present, your straight line will be fitted like this. But actually best fit is this green line. So your machine learning model will be affected if your data set contains outliers. So before going for the machine learning modeling, you have to treat outliers. Another point is these outliers can give you misleading conclusion or the decision. These are the different points why we should handle out outliers. There are different use cases for outliers are very important. So one case is that when you are going to work on the anomaly detection, for example, let's say in medical data, the outliers may indicate a rare disease or unique response to the treatment. So this type of the anomaly detection, outliers are very important. Other use case is fraud detection and network intrusion detection. Next, and the important thing that we are going to understand what are different techniques and the methods that you can use to detect outliers. In the graphical methods, we will look and implement using Python, the Boxplot, Histogram, and Scatterplot, and we'll see that how we are going to use these methods to detect outliers. Other is the statistical methods or the technique. Z-score or Z-score method is there and interquartile range is there. When your data set follow normal distribution or your data set is normally distributed. So most of the time we are going to implement z-score, and when your data set is skewed, so we are going to use IQ or interquartile range. We will see in detail while we are going to implement. There are different machine learning techniques out there like isolation forest, DBSCAN, and different clustering algorithms that can be used to detect outliers. But in this video, we are not going to implement the machine learning techniques because each and every ML techniques will take a lot of time. So we will implement graphical techniques and statistical methods, and then we'll move to how we are going to treat outliers. So one way that you can treat that you are going to remove outliers. If you know that your outliers are because of the errors or irrelevant records, you can just remove these things because we don't need. Okay. Next is that you are going to cap or the floor. In this technique of the capping or flooring, you are going to replace the outliers with the nearest threshold. Okay, so we'll try to understand how we are going to work on this when we are going to implement. Next is imputation. In this, we are going to replace the outlier values by some known values like mean, median, mode, or you can use some model-based prediction values. The fourth and the final technique to handle or the treat outliers is data transformation. In this technique, we are not going to replace or the remove the outliers, but we are going to transform whole data using this log transformation or the square root transformation or reciprocal or power transformations. Okay, after the transformation, the effect of the outlier will be minimized. You are not going to remove or you are not going to replace the outliers, but you need to keep the outliers in your data. So you can use data transformation to minimize the effect of the outliers. So let's move to the implementation. So let's first create a new file, new notebook, and let me write like outliers implementation. So in this, we are going to import different libraries first. So we are going to import pandas as pd, numpy as np, matplotlib.pyplot as plt, and we are going to import stats from scipy and cborn as sns. You can do this one for the matplotlib inline also, and we are going to load basically our dataset as pandas data frame pd.read underscore csv, and this data set that I am going to take. Okay, so this is nothing but enhance weight and height data set. We are going to work on the weight and standing height, these two features. So let me copy the path and put here. Let's display 5 rows. So you can find here weight and height and BMI, all these things are there. Data frame dot shape you can find. So this data frame contains 8,388 rows and 4 columns, these 4 columns. Now let's start on the outliers detection. Okay, so in this we are going to work first on the graphical methods and then we'll move to the statistical methods. Okay, so first we are going to work on the graphical methods. Okay, so in that basically, so first let's work on the box plot. So let me find out different columns. What are the different columns? So I'm going to use these 2 different columns. So to create a box plot, I'm going to use SNS, that is cborn dot box plot. And in that box plot, I'm going to give here data as data frame. You can find here just press shift and tab. You can find here different signature, the signature of the function, that box plot, what it will give you, data x, y, and other things. So for the data, I'm going to put here data frame, and x I'm going to put this weight. You can find here weight, and I'm going to put here the weight like this. You can run this and you can find here. Okay, so remove these things, just do one thing, plt dot show, and just run this one. Okay, This is the box plot, and this is the minimum and this is the maximum acceptable data points in our data set. These are basically whiskers of this plot. This is the box. Box represent middle 50% of the data, and these circles represents the outliers. So using a box plot, if you are getting these type of the circles above this maximum value or the below this minimum value, you are going to say that okay, in this data we have outliers. Okay, so let's do for the next another column, that is standing height. So just to go and copy this standing height, and this one. So what you will get in the standing height, you have some outliers here and some outliers here. Okay, so this way you can find out that whether we have outliers in a particular feature or the column or not. So let's move to the next graphical methods, that is histogram. Okay, so let's create histogram. For this I'm again going to use seaborn sns dot displot. This is very important plot, and we can create a histogram and different plot using this plot. So for this data I'm going to give data frame, and x I'm going to put basically, again you can find here weight. Let's go for the weight first, and what kind of the plot you need. So I'm going to put here histogram. Hist. You can click here and just shift enter. You can find different things, that what different things you have to put. Okay, so kind and all other things you can find. So again you can go for plt.show, just run this one, and you can find that how the histogram looks for this weight column. So for the weight column, we have created a histogram, and using this histogram, we are trying to find out whether in our data set in this column, is there any outlier. So if you focus on the definition of the outlier, what is that? Data points, those are very far away from the most of the data points. So most of the data points, if you check here, lies in between, I think 40 and something like 130 or 140. Okay, and these data points, some data points are even greater than 250 or 180, 200 and something like that. So these data points like 200 and 250 and greater than 250, these data points will be outliers. Okay, so these graphical methods give you some insight that whether our data set or the particular column contains outliers or not. But for exact thing, you have to go for the statistical methods. Let's just do for the another feature that we are going to work on, the standing height. So let's do for the standing height one. That is basically this one I'm going to put here for the standing height. So for the standing height, you will get here, and let me just zoom in. So most of the data points are in between these, like 140 and 190 and something like that. And you can find here that some data points are here, that far away from the most of the data points. So these data points, or this data points that is near to 200, may be outliers. Okay, these are the graphical methods to find out the outliers, to check whether there are outliers or not. So let's move to the another graphical method, that is basically nothing but scatterplot. Scatterplot for the bivariate. So let's create a scatter plot for the weight and height. So for this thing, again I'm going to use sns dot scatter, and again I'm going to put data as data frame, and here x, you can check that what different things you need. So x and y you need, and other things that you can put. Okay, so for x I'm going to put, let's say that I'm going to put here the weight, and y I'm going to put here for the, and y, and the y axis I'm going to put here basically this standing height in centimeter. Okay, so again, I'm going to put here plt.show and run this one, and you can find, okay, let me just do this one. And you can find here weight is there on the x-axis, standing height in centimeter on y-axis, and you can check these data points. Some data points are something like that. They are very far away from the rest of the most of the data points. Okay, so these data points, this one, and all these data points may be treated as outliers. But for confirmation, you have to go for the statistical methods. So let's move to the statistical methods that we are going to work. So in the statistical method, we have to go for the z-score or the z-score and IQR. If your dataset is normally distributed, so you go for the z-score. If your dataset is skewed, so go for the interquartile range. So let me first plot histogram plot for weight and standing height. So just run this. For the standing height, the data distribution is normal or near to the norm. And here for the weight, my data distribution is skewed. To confirm, just go and you can find out the skewness. So you can go for the data frame dot skew. A method is there that will give you the skewness. And you can find here the standing height, the skewness is near zero. So if skewness is near 0 or in between minus 0.5 to 0.5 is near to 0, so those type of the data distribution will be normal distribution. There are different techniques to find out which data distribution is normal distribution and which is not. You can also check normal distribution, whether your data is normally distributed or not, using a QQ plot. So let me write here just the code snippet, and you can find here. So just let me run this one. The QQ plot is a plot between theoretical quantile and whatever ordered values we have in our data set. So these are the values of the standing heights and these are theoretical quantiles. Okay. So if you are getting a straight line or the identical to a straight line, so your data distribution is normal. So here we have seen that standing height in centimeter is normally distributed. So for this we are going for the z-score or z-score, and for this one the skewness of the weight column is more than 1. Okay, so if you are getting skewness greater than 1 or less than -1, so that your data distribution is highly skewed. So for this type of the data distribution, highly skewed data distribution, you can go for the interquartile range. So let's go for the z-score. So let's understand a little bit about z-score and how we are going to use z-score to find out the outliers. So let's understand about z-score first. Basically, z-score measures how many standard deviation any data point is away from the mean. Okay, so it's a little bit tricky to understand what is z-score, but when we are going to calculate z-score, what we will do, we are going to subtract mean from the data point and then we are going to divide by standard deviation of the data. So in this way you can find out this formula: x equal mean plus z-score times standard deviation. Okay, so with this you can find out the formula that this particular data point x is how many standard deviation away from the mean. So that will give you that particular measure that we are going to find out how many standard deviation. Okay, so particularly when we are going to find out z-score or the z-score, so what it will do, this is the mean of the data, and if my z-score is equal to 1, then we are going to find this data point here. So mean plus 1 into standard deviation and mean plus 2 standard deviation, mean plus 3 standard deviation, and same way we are going to mean minus 1 standard deviation, mean minus 2 standard deviation, and something like that. Okay, so it says that if our data distribution is normal distribution, and if you go in this way, like mean plus 1, mean plus 2, mean plus 3, if you go mean plus 3 standard deviation above and below, so most of the data point, like 99.7% of the data points will fall under this. Okay, and if you're going above or below this particular mean plus 3 standard deviation or mean minus 3 standard deviation, so those data points will be treated as outliers. So if you are getting mean plus 3 times standard deviation, any data point greater than this or any data point less than this mean minus 3 standard deviation, so those data points we are going to treat as outliers. Other way we can say that if you are going to find out the z-score of all the data points, and if the z-score is greater than 3, so that particular data point we are going to treat as outlier. And again also, if z-score is less than minus 3, so that data point will also be treated as outlier. This is the convention. You can go for the mean plus 3.1 standard deviation and mean minus 3.1 standard deviation. Okay, but the convention is mean plus minus 3 standard deviation. So let's go and find out the z-score. So z-score, let's say that I'm going to find out height. That we have seen that the height column follows the normal distribution. I'm going to find out the z-score. So again, I'm going to use stats that we already have imported from the SciPy. So stat dot z-score. So you'll get z-score, and I'm going to put here. So basically like this I'm going to use, and if you go for the z-score, the height, after subtracting the mean and dividing by the standard deviation, you will get these values. So let me first make a data frame dot copy. So data frame 1, and in this I'm going to add, basically I'm going to append a column that is height, z-score of height. So z-score height, and in that I'm going to put this z-score. Okay, and let me show you that how this z-score will look like. So up to this we have in our original data frame, and this z-score of the height is added. So if z-score is greater than 3 or less than minus 3, so I'm going to take that sample or that data point as the outlier. So let me just check that whether this z-score is less than minus 3 or is greater than 3. Okay. Before going to this, let me show you one important graph so that it will be easy to understand. Okay. So let me use this snippet that we are going to put here. Data frame 1 standing height and the z-score of the height. I'm going to take this column and this column, and I'm going to plot histograms. Okay, so you can find here this this is the standing height, the original data, and this is the converted data, that is z-scores. So when we are subtracting mean and dividing the standard deviation, you will get these values. Okay, so you can check here the z-score is in between minus 3 and 3. So most of the data lies between minus 3 and 3. So whether you are going to use z-score or you are going to use the original data, it doesn't matter. The distribution is same. And you can use anything like z-score or the standing height to find out outliers. So let's first show me that using this z-score, how I'm going to find out the outliers. Okay, so I'm going to say that if my z-score is less than minus 3 or greater than 3, so I'm going to say that those data points will be treated as outlier. Okay, so this will give you a true false, whether it is true or false. If this particular z-score is less than minus 3, so it will give you true. If not, it will give you false. So basically what I'm going to do, I'm going to put inside the data frame, and it will give me the data points. Okay, so if it is true, then those data points will be there. So see here, z-score is greater than 3 here. This is less than minus 3, less than minus 3, greater than 3, greater than 3, greater than 3. So all the data points, those these scores either less than minus 3 or greater than 3. So we got these data points. These are the outliers. Okay. So other way you can directly go. You can directly go and use these standing heights. So let me show that how can you do this one. So this is something like that. We have written a formula something like x equal mean plus z times standard deviation. Okay, so you have to find out lower value that correspond to minus 3 and the upper value that correspond to 3. So how can you find out? Just very simple. So for the lower point, for this point particular that corresponds to minus 3, we are going to take mean minus 3 times standard deviation. Here Z score we are taking -3. And here for the upper, you can find here for the upper, that is this point that corresponds to 3. So mean plus 3 times standard deviation. So for this, we are going to calculate like this. You can find out. So X lower, how can you find out? Basically nothing but data frame, and I'm going to take which one? Basically, I'm going to take this standing height. So what can I do basically here? I'm going to write a standing height dot mean. This is the formula that it will give the mean plus minus 3 times, basically 3 times. Same thing you can put for the standard deviation. Okay, so I'm going to find STD. This STD will give you the standard deviation and this mean will give you the mean. And same thing you can go for the upper one. Okay, so just go and just do, and let me change here that it will be multiplication. This is multiplied. So you can go and X lower you can find and X upper you can print. So 136 and 196. If any height that is less than 136, so we are going to treat that as outlier. Any height that is greater than 196.8, we are going to treat as outlier. Okay, so let me show that how we are going to use this thing to find our outliers. Let me write first that how I'm going to write it. So this standing height, if it is less than this lower, okay, or we are going to say, and let me copy the whole thing. If this standing height is greater than the upper, x underscore the upper. Okay, so again it will show you like true false, and let me put all these things inside data frame. So this will give me again same thing, that the height that is 198.7 greater than 196. This is 135.3. This is less than 136.4. Okay, so all these things you can find. So in this way also you can go with this, or you can go with the Z score. So same thing, both are same. You can find out the outliers. So let's move to the next one. That is nothing but basically interquartile range. Okay, so in the interquartile range, we are going to see about the skewed data. You can find here the weight is skewed, and we are going to find out the outliers in the weight column using interquartile range. Okay, so let's first understand little bit about interquartile range and how we are going to use interquartile range to find out the outliers. So let's first understand about interquartile range. Interquartile range is the difference between quartile 3 and quartile 1. And if you are getting interquartile range, IQR, you can find out the minimum acceptable values and the maximum acceptable values. So any value less than this minimum acceptable value will be treated as the outlier. Any value greater than the maximum acceptable value will be treated as outlier. So this is the formula for getting minimum one, Q1 minus 1.5 times interquartile range, and for the maximum Q3 plus 1.5 times IQR. Okay, so this uses this box plot. So in the box plot, you are getting these things, Q1 and Q3. Q1 is nothing but 25th percentile. That is, this is a data point. This is a value that represents that 25% of the data are below this particular value. 25% of the data are below this Q1, and this Q3 is nothing but 75th percentile. That says that 75% of the data are below this Q3. The difference between quartile 3 and quartile 1 is nothing but your interquartile range. And using this interquartile range, you are going to check this formula and you will get this maximum and minimum. From here Q3, you are going 1.5 times this IQR, and for this minimum from Q1 you are going below 1.5 times interquartile range. Okay, so from minimum to maximum, these are the acceptable values, and if any value greater than this maximum will be treated as outlier, any value less than this minimum will be treated as outliers. So this is nothing but upper bound and this is your lower bound. So any data that is below lower bound or the above the lower bound will be treated as the outliers. So let me just plot a QQ plot and show you that this is not a normally distributed data. So we are going for this for the weight, we are going for the interquartile range. Okay, and you can go for the box plot that we already have done. Okay, we have already plotted a box plot for the weight and we have seen that there are many data points that are outliers. First, try to understand that how you are going to calculate Q1 and Q3. Then we are going to find out IQR. So first I will create Q1 and then I will find out Q3. Then I will find out IQR as Q3 minus Q1. Okay, so let me just calculate how you are going to find out. You can use NumPy or you can go directly with quantiles, pandas data frame. So I'm going here for the weights. Basically we have the weights now. So I'm going for the weight. Let me copy here the weight and you can just go for the quantile. Okay, quantile function and give here the quantile if you're going for the quartile 1 and quartile 3. So for the quartile 1 you just give 0.25, so you can go here 25th percentile I'm going to find out, and for the quartile 3 that I'm going to find out 75th percentile. Okay, and IQR will be nothing but difference between these two. Okay, Q1. So you can find Q1, Q3, and IQR. Just you can print. So this is 67. That is your this one. This is particularly this point. That is quartile 1. This is 95.8. That is quartile 2. And the difference between these two, that is your interquartile range. Okay, so let me quickly write that what will be the minimum. This particular point, that is basically whiskers. So minimum will be Q1 minus 1.5 times IQR. Maximum will be Q3 plus 1.5 times IQR. So you can find minimum and maximum. Okay, so minimum is 25.2. Okay, so this particular whisker, this is the minimum value. So if any data, here we are dealing with the weight column, so any weight is less than 25.299, so that will be treated as outlier. And if any data, any weight is greater than 138.1, so these data points, these weights will be treated as outlier. Okay, so what we will do, basically we are going to find out this. Just you take this one, just you take this whole thing. So again same logic we are going to apply. If weight is less than this minimum value, if weight is less than this minimum value or the weight is greater than this maximum value, so we are going to say that those data points will be outliers. So this will be the minimum, and let me write like this, or if this is greater than maximum, so it will give you a true false. And again I'm going to put here in the data frame and you can put all the things, so it will give you all these data points. Okay, so all these 207 data points are the outliers, okay, according to this weight. Okay, so these are the outliers using IQR for the weight column. So we have done the statistical methods, two different statistical methods. One is z-score and another is interquartile range. Up to this, we have covered graphical methods and statistical methods. The third way to detect outliers is using machine learning technique. In machine learning techniques, we have different algorithms, different models to find out outliers like isolation forest, DBSCAN, and other clustering algorithms. So using these techniques, we can find out outliers. These are very important and robust techniques to find out outliers. But we are not going to implement these machine learning techniques because each technique in itself is a huge topic. So in upcoming videos, I will try to cover the isolation forest and some other techniques to find out to detect outliers. So up to this, we have covered all the techniques and methods to detect outliers. Now let's move to the treatment. So let's move to the first method, that is removing or the trimming. Okay, so let's first look at how you can remove or the trim the outliers. So what can we do basically, that we already have detected the outliers. So we are going to use those things. So let's say that you have detected using z-score. Okay, so in that z-score we already have calculated z-score, and for that data frame we have done with basically nothing but standing height. Okay, so what I will do, let me just find out z-score of the height. So these are the z-score of the height. So let me show you that what we have done earlier. So what we have done to find out outliers, we have done that this z-score of the height is less than -3. So let me put here inside the bracket, or this particular z-score of the height is greater than 3. Okay, so we have done this thing. We have done this thing to find out the outliers. This will give me the outliers. Okay. But what we have to do, we are going to find out opposite of this. Okay. This is greater than -3. If the z-score is greater than -3 and z-score is less than 3, and put equality also, because here only less than is there, so opposite of less than you are going to put here greater than or equal to, and like this. Okay, so in this way you are going to find out all the data points that are not outliers. So these where the true will be there, those data points are the not outliers. So I'm going to put here, and I'm going to put this into the, and you are going to find out 8381. Earlier it was 8388. So 7 data points were the outliers. And if you are going to put this way, those outliers will be removed. And you can store this whole thing in another data frame like data frame 2 or data frame 3 or something like that. Okay, so this way, using filtering condition, you can find out the data points that are not outliers. Okay, so this is the one way that when you find outliers using z-score. So let's move to the interquartile range. While detecting outliers using interquartile range, we have calculated minimum and maximum values. So let me find out minimum and maximum values that we already have done. Okay, we need not to calculate again. Okay, so these were the minimum and maximum. So same condition, same filtering condition you can use for the weight also. So you can go here and just you can go. So let me do things that data frame, and that we have, what are the columns? Let me find out the columns basically first. So data frame, and we are going for the weight. Okay, so in that, these are the weights, and if the weight is less than the minimum, so what is the logic? Minimum. Okay, so it will give you true or false. And again, I'm going to put here or condition. Okay, and I'm going to find out that we already have done basic to find out the outliers. So if it is greater than maximum. Okay, so this will give you true false. And if you are going to put it inside, okay, if you are going to put it inside data frame, so it will give you exact 207 rows that are outliers. Okay, so what we are going to do, we are going to put the opposite of this condition. Okay, so we are going to do nothing but, greater than or equal to this, and we are going to put and here, and we are going to put here less than or equal to. So if any weight is greater than or equal to minimum value and that is also less than or equal to maximum value, so we are going to say that those data points are nothing but our accepted values, the non outliers. Okay, so 8181, so these are the, after removing 207 rows, we are going to get 8181. These are the data points after removing the outliers. So let me show you one more important thing, that after deleting, so let me first, let's say that I'm going to store this thing into data frame 2. So let me do data frame 2 and let me put this condition, boolean condition, inside this data frame. Okay, and let me put here 2 and data frame 2. Now you will get there is no data point with this condition, so that we have removed the outliers, and now this data frame 2, now this data frame 2 contains no outliers. This way you can remove or trim outliers. So to this we have removed the outliers. So before going to the next method, let's try to understand a very important concept. Let me show first this one, that we are going to use data frame 2 for the weight column. Okay, so sns dot boxplot, and I'm going to take data frame data as data frame 2 that we have done here, and for the x I'm going to take here the weight column. So this is the weight that we are going to use, weight in kg. Okay, so let me write just plt.show. Okay, after removing the outliers, still you are getting some outliers here, as you can see. So what is the concept behind this one? So when you have removed the outliers and you again going to plot the box plot, so still you are going to notice that some outliers are there. Like in this case, we have some outliers. So this is because of that after removing the outliers, whatever the data you are getting, remaining data, for those data, Q1 and Q3 will be changed. Okay. So when Q1 and Q3 is changed, now you are going to get new IQR. Okay, when new IQR is there, so this minimum maximum values, the whiskers values will be changed, and accordingly you may get, it is not always, but still you can get some outliers. Okay, so you have to focus on these things. Let's move to the second way that you are going to treat outliers. That is nothing but you are going to cap and floor, and we will see that what is the Winsorization. So let's move to the next method, that we are going to do the cap or floor. So capping or flooring basically we are going to do. In that we are going to replace the outliers with the threshold. So how we are going to find out the threshold, I will show you with an example that we already have done. So if I'm going to work with IQR, so let me first show here. This minimum value will be threshold for these outliers. Okay, so what we are going to do in this method, capping and flooring, so this minimum value will be my floor value and the maximum will be my cap value. Okay, so any value that is less than the minimum, we are going to replace with this particular value, and any value that is greater than that, this maximum, we are going to replace those values with this maximum value. So this will be basically capping and flooring. I will show you what is the difference between capping and flooring and the Winsorization. So let me first write. So what we are going to do, let's say that I'm going to work for the IQR method. Already you have calculated minimum and maximum. The minimum is 25.299 and maximum is 138.1. So any value, and we are talking about the weight in kg column. Okay, so any weight that is less than 25.299, we are going to replace all those weights by this particular value, and any weight that is greater than 138.1, we are going to replace with this value. How we are going to do? So let me first make data frame that I'm going to copy that original data frame into that, so that I'm not going to make any changes in my original data frame. Okay, so data frame 3, and we are going to take basically, let me first find the columns. what are the different columns. So in that I'm going to take weight. Okay, so this will be the weight column. You can find what are the different weights. So pandas provide a function that is clip. So this function takes these parameters like lower and upper and all these things. We are going to pass these two parameters. Okay, so lower and upper. So this lower, whatever we are going to pass here, so any value that is less than this lower will be replaced by this lower. Okay, and any value that is greater than this upper will be replaced by that value. So here lower is the minimum. So any value that is less than 25.99, we are going to replace with this 25.99. And any value greater than 138, we are going to replace with 138.1. Now what I have to do basically, I have to make this thing, I'm going to assign this particular whatever we have done here, I'm going to assign here. Okay, so now what we have done, we have replaced the outliers by the threshold. Your thresholds are minimum and maximum values. Now you can check the outliers if it's still there are some outliers or not. Okay, so we already have written all these things like weight is greater than maximum or the weight is less than minimum. Okay, we are going to do for all the data frame 3 df3. So okay, you can check here. So now there are no weights that are greater than maximum value or less than minimum values. You can also plot the box plot to check that whether outliers are removed or not. What we are going to do, sns dot box plot, and in that data I'm going to give data frame 3 and x I'm going to pass here and plt dot show. Now you can check that there are no outliers. So outliers are basically removed. You can do this thing like capping and flooring for the z-score also. So let's do that quickly. So already we have done all these things you can find while doing z-score method to find out the outliers, detect outliers. We calculated x lower and x upper values. Okay. So for the standing height, so any standing height that is less than 136.4 centimeter, we are going to replace with this particular value, that is 136.4. And any height that is greater than 196.87 and all these, we are going to replace with this particular value. Okay, so let me write quickly that we already have written. So what I'm going to do, this thing I'm going to copy the data frame into data frame 4 and standing height, same thing that we have done. I'm going to make a clip function and that the lower threshold and upper threshold I'm going to give it as x lower and x upper. Okay, same thing that we have done for the weight one. Okay, so let's do this, and again you can do the same thing to find out if is there any outliers is still remaining or not. This thing. Okay, now you can check that. Okay, there are no outliers remaining. Okay, but keep in mind that this particular thing we have done while doing these things, we used z-score. Okay, but if you are going to find out a box plot for this particular thing, you may get outliers because this box plot uses IQR method. So when you are going for the IQR, after removing the outliers, this box plot will show you that there are no outliers. But if you are going to use any other method like G-score method, okay, so you may get outlier in this box plot. Okay, so don't confuse here that why I'm going to get a outliers. Okay, so let me show you that basically that it will make a sense. Okay, so here standing height is there and data frame 4 is there. Okay, so here you are getting some outliers. Okay, why you are getting some outliers? Because we have used z score or z score to find out the thresholds like x upper and the x lower. But here in the box plot uses a different calculation like IQR methods. In that box plot, this particular upper fence and lower fence are calculated with different techniques like IQR method. Okay, so you may get some differences. So keep in mind this one. So let me make you a little bit understand that what will be the winsorization. In winsorization also we are going to cap or the floor, but what the value we are going to use, that is different. So in this we are going to use percentile. Okay. So we are going to use percentile, any percentile like the upper value or the lower value, we are going to take a percentile. So let's say that we are going to work on this particular IQR or the this weight one. Okay, so weight one we are going to work. So let me show you that how it will work. Okay, let's take this whole thing just quickly so that it will be easy to understand. Let's say that data frame 5 is there and that is data frame dot copy. Okay, and here I'm going to take here that is 5, that is 5. Okay, so before that, this particular minimum or maximum value, what will be that values? Okay, so let's say lower percentile and upper percentile, two things we have, upper percentile. So in that what we are going to do, this particular thing we have, and I'm going to find out quantile. If I'm going to find out lower, let's say that 0.5, okay, and 95, lower percentile and upper percentile. Let me show you. So let me make it 22, not 0.25. Okay, so it means what it will be, it will be 2.5%. Okay, and here I'm going to take 97.5. 97.5. So this is 97.5 percentile, 97.5th percentile, and this will be 22.5th percentile, something like that. Okay, so this will give you any value that is less than this 49.5 weight. I'm going to replace with this particular value. So here the lower and upper threshold, you are going to use any percentile. Okay, so like what will be the percentile, like fifth percentile or the third percentile or the second percentile. Okay, if you want to find out, let's say the second percentile and 98th percentile you are going to take. Okay, so second percentile value is 48.7 and 98th percentile is nothing but 143 point this one. Okay, so now you are going to take the percentile value for the lower and upper thresholds, and you are going to use just you can give here and the upper value that you are going to give for the maximum value. Okay, so you can use this and you can go for the winsorization. Okay, so winsorization is basically general term that uses the threshold as a percentile. Now let's move to the next method, that is imputation. Okay, so let me just find out the copy of the data frame, and in that data frame, let's say I'm going for the IQR method. Let's say that one method that we are going to work, and the next you can do what we have done. I'm going to take the weights. Okay, so this particular thing that I can check. Okay, this is the weight one. You'll get the weights, and now what I'm going to do, if your data distribution is normal, so you can use mean or median, both will be same. Okay, so go for the mean, and if your data distribution is skewed, go for the median. So here now we are going to use median because we know that our weight distribution was skewed. Okay, so we are going to take this median. So let's say that I'm going to use this one, and I'm going to use this median to replace all the outliers, whether it is lower than the minimum or the greater than the maximum. Okay, so we already know that minimum and maximum. If my weight is less than the minimum that we already have done this particular thing. Okay, if any weight that is less than minimum that we already have done, you can find here minimum, minimum and maximum. Okay, so this is 25.29. Okay, if weight is less than minimum or weight is greater than minimum, we already have done many times. Okay, but just we are going to do again. So if greater than maximum, Okay, so what it will show you, it will show true false, something like that. Okay, so if you this is the case, and let me show again, data frame 6 is there, you will get all those 207 rows, all the outliers you are going to get. Okay, but what we are going to do, we are going to take this whole thing. Let me do something like that. I'm going to take these particular values, okay, these particular outliers, and I'm going to say that for these 207 rows and columns, I'm going to say that I'm going to work on only the weights. Okay, so here I'm going to pass the weights. So data frame 6 dot location, and in that location this whole thing will give me all the rows, okay, all the rows and columns, and this particular column will say that okay, I'm going to take only this weight column. Okay, if you check this one, this will give you these things. Okay, these are the indexes and these are the weights. Now I'm going to say that I'm going to replace these values that are less than 20, the weights that are less than 25.9 or greater than 138.1. I'm going to replace with the median. Okay, if the weight is less than the minimum or the weight is greater than the maximum, so those weights will be replaced by this median that we have already calculated. So this was 79.9. Okay, so what can you do? Basically, one thing that we already have done here for the weight one, that I can do. Okay, I can take this one whole thing and I'm going to do here also. So just do 6. So I'm going to check that whether any value that is greater than maximum or less than minimum is remaining or not. Now, okay, we have replaced all the outliers values by the median. That's simple. Whether it is less than minimum or greater than a maximum. So you can do same thing using your z-score. That is very easy. So this particular thing I am leaving for you. Now let's move to our next and the final method for outlier treatment, that is our data transformations. So when we do data transformation, it doesn't remove or the cap the outliers. Okay, we are not going to remove or the cap or the impute the outliers, but our outliers will remain in the data set, but the effect of the outliers will be minimized. If our data distribution is not normal, like skewed, so after applying any transformation like log transformation, reciprocal transformation, or the square root, or these power transformations, the data distribution more likely will be the normal distribution. So let me do something. Let's say that I'm going to copy the data frame into df7. Okay, and in data frame 7 I'm going to use, let's say that we are going for the weights. You can go for the height, but height is already normally distributed, so let's say that we are going for the weight one. Okay, let me do one thing. Basically, let me just plot sns dot distribution plot so that we can understand how it will look. You can directly put this whole thing as the input. This will, by default, it will take as x, plt dot show. Okay, so my data distribution is something like this. Okay, that is a skewed. I'm going to apply log transformation or any other transformation. You can check. I will apply log transformations, and you can go and check one by one transformations. Okay, so square root directly you will get from the numpy, and reciprocal just you go for 1 over x, and for the box cost transformation you have to import it from the scipy. Okay, so what I'm going to do, I'm going to basically transform this. I'm going to take numpy dot log, and within this I will put like this. So if you go and you can check here, my original weight were 97.1, 98.8, 74.3, okay, something like that. After transformation you can find out 4.5, 4.9, something like that. Okay, now let me just store this into the data frame, and let me again plot the distribution. Okay, Now you can find here the distribution is more likely a normal distribution. You can check the skewness, mean and median, all these things. So this way you can go for the data transformation. I will upload this notebook along with the dataset on the GitHub, and go and download the notebook and the dataset, and you can practice. And let me know any particular topic that you want to explore in more detail.